Hey guys, welcome back. This time around, we're going to continue our discussion on the language of chemistry, and in particular, we're going to be looking at chemical bonds. Before we do that, let's take a few moments just to reflect on what we already know. We know that there are a number of elements that we can identify from the periodic chart. There's a number of things from the periodic chart that we can identify, such as the atomic symbol, which are the letters that represent a given element, the atomic number, which tells us the number of protons, and the number of electrons as read from the periodic chart, and the atomic weight, which we can round off to get the number of neutrons. We know that these elements can be found in our body as electrolytes, such as sodium and potassium. We also know that they can work together to create larger structures known as molecules. These molecules can be molecules of an element or molecules of a compound. And we further know that the individual compounds can physically intermix to make mixtures. And we identified three types of mixtures that we have: solutions, suspensions, and colloids. Now we need to back up and say, what is this relationship that allows for given atoms of elements to interact with one another to make compounds? Now when we're talking about elements doing this, it all deals with the stability factor. As read from the periodic chart, we know that each element is electroneutral, but is it stable as read from the periodic chart? And that to be able to answer that question, we've got to first identify what are chemical bonds and what is it about a chemical bond that makes an element stable. A chemical bond is going to represent an energy relationship between electrons of reacting atoms. Not just any electrons, but it's going to be those electrons that are going to be found on the outermost energy level of that atom. These electrons are going to be known as the valence electrons. And they're going to be found in an energy level known as the valence shell. The valence shell will be the outermost energy level. It will contain the electrons that are capable of having an interrelationship with other atoms, a reaction, an energy relationship. And these are known as chemical bonds. What governs whether an atom is going to be chemically active with other atoms? Well, that's something known as an octet rule. An octet rule says for an atom to be stable, it must obey one of two rules associated with the octet rule. The first rule would be that the outermost energy level is full. The second rule would be that the outermost energy level has 8 electrons in it. If either part of this rule are obeyed by an atom, then that atom is not going to be reactive in nature. It's going to be stable in nature, and it's going to be known as a noble gas or an inert gas. The vast majority of elements, though, that we look at on the periodic chart are not going to obey the rule of 8. So they're going to have chemical relationships, energy relationships with other atoms in such a way in which they can satisfy the rule of 8 by having that relationship. Let's look at a few examples of how this can happen in nature. Let's start by looking at hydrogen. When you take a look at an atom of hydrogen, how many protons are found in the atom of hydrogen? I hope you tell me 1. And as written from the periodic chart, every element is electroneutral. So if there's 1 proton, there must be 1 electron. Now where would that electron be found? It would be found orbiting the atomic nucleus of that atom of hydrogen, and it would be found in what we know as energy levels. Now the question would be then, if you have 1 electron in the outermost energy level of hydrogen, then the valence electron for hydrogen would be 1, and the energy level in this case would be 1. Now this first energy level is going to hold 2 electrons to be full. So is hydrogen atoms stable in nature as written from the periodic chart? Does it obey the rule of 8? It does not, because the outermost energy level in this case holds 2 to be full, and it only has 1 with hydrogen. Now let's look at helium. How many protons are found in the atom of helium? Hope you tell me 2. Number of electrons, 2. Let's place those electrons in that first energy level, because we always fill up the first energy level before we go to the next energy level. Now, is helium stable as written from the periodic chart? It is electroneutral,
but is it stable? Does it obey the rule of 8? Rule of 8 says the outermost energy level needs to be full or obtain or have 8 electrons in it. In this case, the first energy level only holds 2 electrons. To be full, so helium actually is stable in nature. It's known as a noble gas or inert gas. Let's look at lithium. Lithium has 3 protons. It has 3 electrons. Let's put those electrons in. The first 2 go in the first energy level. And the third one then goes into this second energy level. Now this second energy level, to be full, holds 8 electrons. Now is lithium stable as written from the periodic chart? To be stable again, its outer energy level must be full, or its outer energy level must hold 8 electrons. So lithium is not stable, but how many valence electrons does lithium have then? It has 1 valence electron, this one in the outermost energy level. And what is the outermost energy level? The outermost energy level is the second one. Let's look at beryllium. Beryllium has 4 protons, has 4 electrons. The first 2 go in the first energy level. The other 2 will go in the second energy level. Notice I'm putting them as far away from one another as I can. How many valence electrons does beryllium have? It has 2 valence electrons. The valence electrons are those found in the outermost energy level. Is beryllium stable as written from the periodic chart? Hope you tell me no, because the outer energy level does not have 8 in it, nor is it full, because this outer energy level holds 8 to be full. What is the valence shell? 2. Let's go to boron. Boron has 5 protons. It has 5 electrons. Let's put those electrons in place. The first 2 go here. The last 3 go into the second energy level. So how many valence electrons does boron have? It has 3. And what energy level are those valence electrons found in? The second one. Is it stable? No. Go to carbon. How many protons does it have? It has 6. How many electrons does it have? It has 6. Put the first 2 electrons in the first energy level. We fill it up. We move to the next energy level, which is the second energy level that holds a maximum of 8, but in this case for carbon it will hold the remaining 4. So the valence electrons in the carbon atom are going to be 4, and the valence energy shell is going to be the second one. Look at nitrogen. How many protons? It has 7. How many electrons? It has 7. The first 2 go here in the first energy level, and then the remaining 5 go into the second energy level. So how many valence electrons does nitrogen have? It has 5. Those are the 5 in the outer energy level. And the outer energy level, or the valence shell, is going to be the second one. Take a look at oxygen. Oxygen has 8 protons. It has 8 electrons. The first 2 electrons go on the first energy level. The remaining 6 go into the second energy level. The number of valence electrons in an atom of oxygen is 6. And the valence shell is the second one. Look at fluorine. Fluorine has 9 protons. It has 9 electrons. The first 2 of those 9 electrons go in the first energy level. The remaining 7 go in the second energy level. Now, is the number of valence electrons that are found in the atom of fluorine, is it going to be 9 or 7? Hope you tell me 7, because it's only going to, the valence electrons are only those electrons found in the outermost energy level, which is the second energy level. Is fluorine stable as written from the periodic chart? No, because it does not obey the rule of 8. It does not have 8 electrons in its outermost shell, nor is the outermost shell full. Look at neon. Neon has 10 protons, 10 electrons. The first 2 go in the first energy level. Then we put the remaining 8 out here in the second energy level. How many valence electrons does neon have? It has 8. They're found in the second energy level. Is neon stable as written from the periodic chart? I hope you tell me yes, because it obeys the rule of 8. or the octet rule, which says that it has to have either 8 electrons in its outermost shell, which it does, or its outermost shell has to be full, which in this case it is full, because the second energy level only holds 8 electrons. Now let's look at sodium. Sodium has 11 protons, has 11 electrons. The first 2 go in the first energy level. The next 8 go in the second energy level. That energy level is going to be full with those 8 electrons. So the third energy level has to be brought into play so that it can hold the remaining electron. So while it has 11 electrons, how many valence electrons does an atom of sodium have? It has 1 valence electron. And what energy level is it going to be found in? It will be found in the third one. The last one we'll look at is magnesium. Magnesium has 12 protons and 12 electrons. The first 2 go in the first energy level. The next 8 go in the second energy level. And then that leaves us with 2 to go in the third energy level. How many valence electrons are going to be found in an atom of magnesium? I hope you tell me 2. How many electrons in an atom of magnesium? I hope you tell me 12. What energy level will the valence electrons be found in? I hope you tell me the third one.
Now that you've had a chance to actually look at several examples of elements and how we can identify the valence electrons using the energy shells and drawing their circles, got a quick question for you. Is there a way in which we can cheat by using a periodic chart to help us identify the valence electrons and the valence shell without drawing our circles? We'll go back and look at that periodic chart. If you recall, the periodic chart is going to be, the elements are going to be identified in the periodic chart based on the columns and a row sequence. Now go back to what our examples were. Look at hydrogen. Look at lithium. And take a look at sodium. How many valence electrons did each of those elements have? If you recall, they had 1. Now what column is hydrogen, lithium, and sodium in? They're in column 1. So thus the column will tell us the number of valence electrons. Let's try that out. Let's go over and look at carbon in this example. What column is carbon in? Roman numeral 4. How many valence electrons does it have? 4. Look at nitrogen. What column is it in? Roman numeral 5. How many electrons does it have in its outer shell? Valence electrons, 5. So we can use the column numbering to tell us the number of valence electrons. Now tell me, what's the difference between hydrogen and lithium as far as where that valence electron is found at? Remember, hydrogen is found in the first energy level, lithium it's found in the second energy level, and in sodium it's found in the third energy level. Now take a look at your periodic chart. What row is hydrogen in? 1. What row is lithium in? 2. What row is sodium in? 3. So catch it. You can find out the number of valence electrons in a given atom of an element by looking at its column. And you can determine which energy level that valence electron is found in by looking at the row it's in. Try that out. Go look at sulfur. Sulfur has an atomic symbol of S. How many valence electrons does it have? And what energy level would those valence electrons be found in? I hope you tell me it has 6 valence electrons, and I hope you tell me they're going to be found in the third energy level. Try that out for potassium. How many valence electrons? What energy level? I hope you tell me it's got 1 valence electron in energy level number 4. Finally, take a look at bromine, which is Br. Number of valence electrons, 7. Energy level, 4. Have a good day. See you.